Okay, Assalamu alaikum. I hope all of you are doing good and you are not very stressed about your exam. Alright, so there were some confusions. As I said, that I am going to address all the confusions that you people have. So I've been getting questions about arc elasticity and point elasticity, and there is some confusion about how can one topic be covered in so many questions. So I'll try to answer those questions quickly, but first let us quickly go through arc elasticity, right? So now the curves, the demand curves that you will get will be of two types. They are going to be either a straight line, which are called linear curves, which we did in class, but sometimes the graph is it's not a straight line, it's a curve. So that's called a non-linear demand curve. So how do you find elasticity on that? There is no straight line, so how will you measure the elasticity along that curve? When we do point elasticity, then I'll show you that it's very easy to measure elasticity at any point on a straight line. But how do you do it when it's a curve? Alright, so it's very simple. You take the distance between 2 points and draw a line, right? So let's look at this graph. Okay, so let's look at this graph. Okay, I'm using a very outmoded method of teaching. There is no smart board here and there's no whiteboard here, so you will have to forgive me for that. Please bear with me, but please do have a look at this graph. This graph is a curve. All right, there's no straight line. So, and there are 2 points identified on the curve, point A and point B. Please ignore the formula on the right. That is not the formula that I will use. I will not use the formula from any book, and I'm not going to use the formula, and you are not going to use this formula. We're going to use the formula that I give you. Don't even use the formula in the slides. I don't like it. All right. So let's look at the curve, point A and point B. These are 2 points that we have identified. All right, and then we make a straight line connecting these two. Right, now that we have a straight line, now it's easy for us to calculate the elasticity. Right, you can assume anything. You can assume that you are moving from point A to point B, or you are moving from point B to point A. Movement along the curve. Please remember that. Contraction, extension of demand. Right, I'm not going to repeat that because I assume that you know that already. So, but in this graph, he is assuming that we are moving from point B to point A. Why is he assuming that? Come on, answer. Why is he assuming that? Because P1 corresponds to B. So that's the starting point. And from P1, he is moving to P. All right. So, but the movement can be in any direction. You can move from P1 to P2. You can move from P2 back to P1, but here we are moving from point B to point A. Someone else might say, oh my god, this is not a movement. The P was the original point because it corresponds to point A, and now we are moving to point P1. So you can move in any direction. The formula for calculating the elasticity will remain the same. So now let's go back and I will give you the formula. The formula to calculate price elasticity, arc elasticity is Q1 minus Q2, all right, Q1 minus Q2 divided by Q1 plus Q2, multiply the whole by P1 plus P2 divided by P1 minus P2. This is the straightforward simple formula that we are going to use. In the first part of the formula, we are dealing with the quantities. In the second part of the formula, we're dealing with the price. All right. We always start with 1. In the numerator, we start with Q1. In the denominator, we start with Q1. So we are always starting with the first quantities. But in the quantity bit, we minus Q2 from Q1. And in the denominator, we add Q1 to Q2. That's the reverse when we are doing with the price. In the price, P1 is added to P2 and P1 is then minus from P2 in the denominator. Please learn this formula. This will stand you in good stead. I have given it 2-3 times, and you need to practice it only once or twice. All right. Now please look at the graph. The graph. Which graph am I talking about? I'm talking about this graph. Okay. Please look at this graph very, very carefully. Okay. Now here there are 2 points. In this graph there are 2 points, point B and point A. Alright, ignore this calculation. This is not the calculation that I want. I will give you my own calculation, but the graph is relevant. The graph is good. So let's look at point A. At point A, the price is 10, and at 10, the quantity demanded is 1000. At point B, the price is 11, the quantity demanded is 900. Now, in the first instance, what are we assuming? That we are moving from point B to point A. The starting point is B and the finishing point is A. So what are we going to see here? Are we going to see an extension or a contraction? Yes, Shajil, tell me, what are we going to see here? Are we going to see a contraction or an extension? The price has fallen, there's a movement along the curve, so there's going to be an extension of demand. Right? There's going to be an extension of demand. So now let's start plugging this into the formula. The formula is Q1 minus Q2. Q1 was 900, right? We started from point B, so the Q1 was 900, Q2 was 1000. Q1 was 900, Q2 was 1000. 900 minus 1000. And then in the denominator, Q1 is 900, Q2 is 1000. So we add the two. Now when we add the two, 900 minus 1000 is minus 100 divided by 1900. Your answer is going to be, please verify this, it's going to be 0.052. Right? You multiply it by 21. Where do you get 21 from? Your starting point here. Now look at the price. Now look at the y-axis. Your starting point was at point B was 11, so we start with P1 was 11. We add P2, which is 10, that makes it 21, and then we minus P2 from P1, so 11 minus 10. That is what? That is 1. So 21 divided by 1 is equal to 1. That's the answer, is equal to 21. So 21. So 0.05 multiplied by 21 is, what is it? Minus 1.1. All right, that's, if you calculate it, that's the answer you're going to get, minus 1.1. Okay, now reverse the process. Okay, yes, I'm talking to everyone. Okay, Vijay, now you can reverse the process. Can you reverse the process? What do I mean by reverse the process? Reverse the process means the starting point is not B now. The starting point is A. We were at A. What was the price at A? 10. What was the quantity at A? 1000. Okay, so P1 was 10 and Q1 was 1000. Right? Now price rises to 11. We move from A to B. Okay, when we move from A to B, here is your calculation. The formula remains the same. Okay, the formula remains the same. Q1 minus Q2 divided by Q1 plus Q2. Multiply the whole by P1 plus P2 divided by P1 plus P1 minus P2. The formula is exactly the same. But what are we going to do now? The Q1 now is not 900. We started from point A, right? So the Q1 now becomes 1000. Okay, and Q2 now becomes 900. So 1000 minus 900 divided by 1000 plus 900. It's the same. It's 100 divided by 1900. Exactly what we got there. Multiply this by what? Now P1, previously P1 was 11, now P1 is 10 plus 11. Numerator is 21, but the denominator is now not 1 but minus 1. Why? Because P1 was, correspond this, P1 was 10, P2 was 11. We have to minus P2 from P1. So P1 was 10 minus 11, the answer is minus 1. So if the answer is minus 1, your answer again will be minus 1.1. So your arc elasticity here is minus 1.1. Simple calculation, nothing very complicated. Okay. So practice this once or twice, and I'm very sure that you will not have a problem in this, and the questions will be based on the same. So I hope you are following this, and please, yes, there are 3 questions related to the same concept, but in the first you just have to give me a theoretical explanation and a theoretical definition of what point and arc elasticities are. Alright, that's the first thing that you have to do. Right? In the second, there is a calculation. So I've given you the calculation. If you practice this calculation, then that's a numerical calculation which you will have to do. The calculation is just about remembering the formula. Alright, so there should not be a problem in this. I'm also going to upload a video quickly about point elasticity, because that is very, very simple, but you will have to use point elasticity to prove that elasticity is changing throughout the curve when the curve is linear. Okay, that it's not just about giving the definition. You have to know the definition and the explanation, but you have to prove using the example that I've given you. You have to prove that the elasticity is changing. Please, you have to draw the graph, and using the graph you will give a mathematical illustration showing that the elasticity is changing. Okay, when you do point elasticity. Arc elasticity is a straightforward question. You have to give me the concept what arc elasticity is based on exactly what I've taught you here, and then I'll give you a question, a numerical question. Please practice this question, and there will not be a problem, inshallah. Okay, best of luck. I'm going to upload the point elasticity now.